Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 4.2 entitled Graphing Linear Equations. And today we're going to determine if an ordered pair is a solution of an equation. We're going to write an equation in function form, which means we're just going to solve the equation for y. And we're going to make a function table and then use it to graph an equation. But before we get to that, we have to talk about the standard form for a linear equation. And standard form is this equation right here, ax plus by equals c. And since we're talking about graphing, we're going to start graphing different types of equations, and there's three basic forms to equations, and this is the first of them. And a and b and c are all just going to be numbers. It could be positive numbers, they could be negative numbers. However, we don't want any fractions or decimals. And a must be positive. So those are the two guidelines that we have to follow when we're dealing with standard form. Those guidelines aren't as much of an issue in some of the other forms that we'll be working with, but for now, when we're starting with standard form, those are just the rules that we have to follow. And they're going to give us an equation in standard form, and then they're going to give us an ordered pair, and we have to see if that ordered pair is a solution to the equation that we're given. And basically, to test that, we're just going to take the ordered pair, x and y, and substitute it into the equation for x and y. And then we'll multiply a times x and b times y, add them together, and we'll see if we get c. If we do, that ordered pair is a solution. If we don't, it's not a solution. So here's what we're going to work with in example 1, where we're determining if an ordered pair is a solution. Now they gave us this equation here, x plus 5y equals 3. Notice that's in the standard form. Okay, there's a 1 in front of the x, so that's our ax plus by equals c format. And for our ordered pair, remember the first number is x and the second number is y. So those are the values that we're going to substitute into this equation that they gave us. So I'll have 1 times negative 2 plus 5 times 1 equals 3. And now I'm going to see if the left side equals the right side. So 1 times negative 2 is negative 2. 5 times 1 is 5. And negative 2 plus 5 is 3. And 3 does equal 3. So yes, that ordered pair is a solution to that equation. That means if we graphed that equation, that ordered pair, negative 2, 1, would be on the line when we graphed it. Okay, for part B, we're going to practice the same thing. I just have different numbers now, x and y. And there's no shame in labeling those values x and y so that you know you're substituting the right value in for the right variable. And we're using the same equation. In your homework, that might give you one equation and several ordered pairs to use, or they might give you a separate ordered pair and a separate equation for every problem. So I have negative 7 minus 10 equals 3. And negative 7 minus 10 more is a negative 17, which does not equal 3. So no, that ordered pair is not a solution to that equation, which means, again, if I graphed that equation, this ordered pair would not be on it. Now, we're also going to deal with stuff that's called function form, and this is when you have a two-variable equation that's written in a format so that one of the variables is isolated. And basically, the variable that we're going to isolate it's going to be y. So whenever you see that phrase function form, you want to just solve for y. So again, they're going to give us an equation that's written in standard form, and we're going to rework it so that it's in a different form. And when we're solving for y, this is actually called slope-intercept form, which is another form that we're going to be working with later on. But for now, they just call it function form to get you practicing working with it. So for part A, in example 2, it says to rewrite the equation in function form. Again, that means to solve for y. So if you need to, take this first equation, 2x plus y equals 4, and box in the y. And I have to get rid of the 2x that's being added to the y. And how I get rid of that and move that to the other side is I do the opposite operation. I'm going to subtract the 2x. So this is very similar to all the equation solving that we did in chapter 3. So now the y will come down. And you can technically write this either way. You could write it 4 minus 2x, or you could write it negative 2x plus 4. I want you to write it negative 2x plus 4 because we want the x term to come first and then the numerical term. They're not like terms, so I can't combine them together. And even if you wrote it y equals 4 minus 2x, that's not wrong. But this format is slope-intercept form, which again, we're going to practice later in the chapter. So if you get into the habit now of putting the x term first and then the number, it'll be super easy and second nature to you by the time we get to it later on. Okay, for part B, we're going to do the same thing. We're going to solve for y, except now the y has a number that it's being multiplied by as well. So I'm going to box in the y, and I know I have to get rid of the 6x by subtracting it over to the other side, and I have to get rid of this minus 3 or this negative 3 by dividing it to the other side. And when I have an addition and subtraction and a multiplication and division step that I have to undo, remember we undo the addition or subtraction first. So I'm going to subtract the 6x to the other side of the equation. I'm going to move him over to the other side. Now I still have the negative 3 times the y. Don't forget about this minus in front of the 3. Think of it like a minus 3 or a negative 3. He's got to stay in front of the 3. A lot of times students forget that. And then the 18 and the 6x are not like terms. I can't combine them together, but I'm going to write the 6x first, and then the plus 18. I want it to be plus 18 because 18 is positive. Now I still have to solve for the y, so I have to divide every single term by negative 3. Now in the past, what we did to one side, we did to the other side, and we just had to do it one time on each side of the equation. However, on this side of my equation, the right side, I have two things. I have two terms over here, and I have to divide each of them by the negative 3. So here the negative 3's will cancel, and I'll have my y by itself, and then I'll have negative 6 divided by the negative 3. That I can do. I can take those numbers and divide them, which is 2, and then I just put the x behind it. And then the 18 divided by the negative 3, that's a negative 6. So I'll have 2x minus 6. So there were a lot of steps that we went through in that problem. So we're going to practice those steps again in part C here. So I have 4y minus 3x equals negative 28. Again, I'm solving for that y. I have to undo this multiplication by 4, and I have to undo this subtraction by 3x. And that's what I'm going to undo first. So I'm going to add the 3x over to the other side. I'm going to undo that addition and subtraction first. So then I'm going to bring down my 3x first, and then the minus 28. I'm going to do a minus 28 because it was a negative 28 up there. I'm almost done, but I still have one more step to get the y completely by itself. I have to divide by 4. And I'm going to divide everything by 4. So y equals, now here I can't divide the 3 by 4, so I'm just going to leave it 3/4. And now put the little x behind it. So just think of it like a fraction and then x. And then 28 divided by 4, I can do that. That's 7. So if you end up with a fraction, leave it as a fraction. Just make sure that you reduce your answer, or reduce your fraction as much as you can. Don't make it 0.75, because in the future, that number is going to be our slope. And we want slope to be a fraction, not a decimal. So when we're solving an equation for y and we're putting it in function form, that's very, very similar to solving an equation like we have done in the previous chapter. Now we have example 3 and example 4 left, and what we're going to do here is we're going to practice making a function table. And it might be called a function table or a table of values, but the directions will say to find 3 ordered pairs that are solutions to the given equation. So this is kind of going back to example 1, where they gave us an ordered pair and we tested it to see if it was a solution. Now we're going to pick the ordered pairs. So how we do this is we make a little function table. X, and then we'll have our work, negative 2x plus 1, that's my function. Y equals is already solved for. And then I have my y. Now, I get to pick and find what ordered pairs are going to work in this equation. So I'm going to pick the values I want for x. I'm going to pick nice, easy numbers. 0, 1, and 2. They're all little, they're all positive. You can use any number you want, though. You could use negative numbers, you could use big numbers. If your favorite number is 21, you could use that. If you like 99 or 500 or 3 million, you could use those numbers too. But keep it easy, keep it simple. Pick 3 small numbers that are easy to substitute in. And then we're going to do negative 2 times 0 plus 1. So I'm going to substitute in that value that I picked for x into the equation for x. Negative 2 times 0 is 0, plus 1 is 1. So then 0, 1 will be one of my ordered pairs. That's a solution. So I'll write that down here. 0, 1. We're going to write it as an ordered pair. Okay, then I'm going to substitute in the 1. Negative 2 times 1 is negative 2, plus 1 is negative 1. So then 1, negative 1 is going to be one of my solutions. And then I'm going to substitute in the 2. So negative 2 times 2 is negative 4, plus 1 is negative 3. So another solution to that equation is 2, negative 3. So those are my 3 solutions for that equation. There are infinitely many solutions to this equation. These are just 3 that I picked. The direction said find 3. Your 3 might be different than somebody else's as well, and they could all be completely correct. Now part B is slightly different because the equation isn't solved for y already. And it doesn't have to be. You can make a table of values and not have the equation solved for y. But I think it's easier if it's solved for y. So I'm going to take a moment and I'm going to put this in function form. I'm going to subtract the 4x over to the other side. So I'll have y equals negative 4x minus 3. So when I make my function table, that's my function that I'm going to put in the middle column. And again, I can pick any number that I want to pick. I can pick 0, 1, and 2, or I could pick, oh, I don't know, 0, 2, and 4. So negative 4 times 0 is 0, minus 3 is negative 3. And negative 4 times 2 is negative 8, minus 3 is negative 11. And negative 4 times 4, that's negative 16. minus 3 is negative 19. So then each x and y value will be one of my ordered pairs. So those are my 3 solutions for that equation. And again, my 3 solutions might be different than somebody else's, and that's okay. Now this last equation, again, it's not solved for y, so I'm going to solve it for y. It's a little trickier to solve this one for y because there's really 2 things going on with the y. I have an x that's being added to it because the x is positive, and then I have a negative or negative 1 that's being multiplied by the y. So I'm going to undo that addition or subtraction first. I'm going to move that x over to the opposite side. Now again, I'm still trying to solve for this y, and this negative in front of it, remember there's a negative 1 there that's being multiplied by the y. So that's what I'm going to divide by to get the y completely by itself. So my equation now will be y equals x minus 6. So it's a fairly simple and straightforward equation, but it's a little tricky to rework the equation and solve. But once we have it solved, it's very easy to pick some numbers and substitute in. And again, I don't always have to pick 0, 1, and 2, or 0, 2, and 4. I could pick 9, 8, 7 if I wanted to. So 9 minus 6 is 3. 8 minus 6 is 2. 7 minus 6 is 1. And there are my 3 solutions. 9, 3, 8, 2, and 7, 1. Now I could have picked 0, 1, and 2. And when I would have done that, I would have gotten negative numbers for my y values. And that's completely okay. Okay, last example then is to use a table of values to graph these equations. So we're going to do basically what we did in the previous example, and then we're going to graph those ordered pairs. Now you need at least 3 points to make a graph of a line. Sometimes you can use 2 points, but that's an x-intercept and a y-intercept, and we haven't really talked about that shortcut strategy yet. So I want you to pick 3 ordered pairs, find 3 solutions, and graph them. So again, we're going to make an x and a y table. And I'm going to leave off this middle column because you don't always have to have that middle column where you have your work. So I'm going to pick 0, 1, and 2. Now I'm going to do the substitution kind of in my head. Okay, I'm going to substitute 0 in for x. 5 times 0 is 0, minus 2 is a negative 2. And substitute in a 1. 5 times 1 is 5, minus 2 is 3. Then I'll substitute in the 2. 5 times 2 is 10, minus 2 is 8. And then these are going to be my ordered pairs. So it's nice when you leave out that middle column where you're showing your work, because then your ordered pairs are kind of written right next to each other. Now, you can certainly do that middle column and show that work, okay? But then after you have your ordered pairs, you need to plot them. So 0, negative 2 is my first point. 1, 2, 3 is my second point. And 2, 8 is my final point. And then since we are making an equation and it has infinitely many solutions, I want to connect them and put arrows at the ends of each. Don't stop at the very last point and put your arrow right at that last point. Draw a little bit past it and then put your arrow. Okay, and for part B, now this is kind of like part B and C in example 3, where the equation wasn't solved for y. So again, we're practicing what we did in example 2, where we're going to write it in function form. So I'm going to solve for y first. And to do that, I'm going to subtract the 3x over. I got to get rid of that addition or subtraction first. So then I'll have negative 2y equals negative 3x plus 6. So I'm kind of finishing my work over here. And then I still have to divide everything by the negative 2 so that I can get the y all by itself. So y equals, now negative divided by negative is a positive 3/2. I know that's an improper fraction, and that's okay. I can leave it an improper fraction. It's reduced as much as it can. And I'll have 6 divided by negative 2, that's minus 3. So there's the equation that I'm going to be graphing, and it's in function form now. And I'm going to make a function table. Now, I want to be smart here about the numbers that I pick for this table. Any number I pick, I'm going to multiply it by 3/2. So ideally, I want a number that if I multiply it by 3/2, the 2 in the denominator will cancel. Now, I can multiply anything by 0 and just get 0. So I'm going to pick 0 because 0 will just make that fraction go away. So 3/2 times 0 is 0, minus 3 is negative 3. A number that I know will cancel with the 2 in the denominator is going to be 2. So if I have 3/2 times 2, or 2 over 1, those 2's cancel. When I multiply across the top and the bottom, I'm just going to get 3. So when I substitute 2 in here, 3/2 times 2 is just 3, and then 3 minus 3 is a 0. Pretty slick. I don't have any fractions that I have to worry about graphing. And my last number that I'm going to pick, I could pick negative 2 if I wanted. But I have to pick another number that will cancel with the 2. So I'm going to pick 4. If I do 3/2 times 4, the 2 is going to cancel with the 4 2 times. So then 3 times 2 is 6. So 3/2 times 4 is 6, minus 3 is 3. And there are my 3 ordered pairs that I can use to graph my equation. So I'm going to plot 0, negative 3, and 2, 0. So that'll be on the axis. And then 4, 3. And again, I'm going to connect them with a line, make it as straight as you can, and then put arrows at the end. So there's a lot of steps here in these problems. Take your time, go through each one. This is very important algebra, though. Being able to graph an equation is a fundamental algebraic skill, and you will do it in geometry and algebra 2 and trigonometry and calculus. So you really need to master this skill now. So definitely practice these problems. If you need graph paper, make sure you get some from my classroom, or there are a bunch of free websites online. You can just Google graph paper and you can print off your own graph paper. If you have any questions, come on in and see me before school.